Activity 12.1, sliding, flipping, turning, and scaling has to do with transformations. And this is one of those topics in mathematics that can start in kindergarten and go all the way up in to college mathematics. The very first one is a slide. And we're going to do this on a coordinate system, which makes it a bit easier. What you need is you need a pre-image. So we have a square given, and you need a vector. So the very first part is the slide square ABCD using vector EF, and you trace it. So if you look at EF, it goes 1, 2, 3 units to the right. So 1, 2, 3 units to the right would be your C, and we call that prime for the image. And then we have 1, 2, 3 up here, 1, 2, 3 here, and here. So this is A prime, B prime, C prime, D prime. And this is the image of square ABCD along vector EF. If you look at B and you have vector GH, you go 1, 2, 3 units down, 1 unit to the right. So you take each point, you go 1, 2, 3 units down, 1 to the right, 1, 2, 3, 1 to the right. So here's my D prime, C prime. And we are starting with the original square again. You can make a double image. We're not doing that for this one. And that is the image of square ABCD along vector GH. If point A is at -4, 3, and that's on the coordinate system. So right here, I have point A, which is at -4, 3. I want to figure out where it is, where A prime is after moving it along vector EF. Well, it goes to the right 3. It looks like it is at -1 and 3. And then the same question, your A is at -4 and 3. If you move it along vector GH, where did it end up? And it ended up 1, 2, 3, -3 and 0. We should make ourselves a little note that for any translation or slide is we need a distance and direction. And that's exactly what a vector gives us. You need to know how far you slide your image, your pre-image, and in what direction. The second type of transformation is a reflection, also called a flip. We've done some reflection lines or lines of symmetry when we're looking at symmetry. This is outside of it, but we do create this mirror image. A is flip the square across the y-axis and trace it. So the vertical axis is the y-axis, and we want to flip it over. What we don't see when we do this on paper is we actually end up with the image flipped over so you see the backside of it. So if I had the physical manipulative, and I still have, this kind of looks like our pattern blocks. They're not going to quite fit, they're bigger. But let's say I have this and I put a big dot here. If I flip it over the y-axis, I would no longer see that dot. So I see the backside of it. Okay, so for this one, it's 3 to the right. So 1, 2, 3 to the left. There's 1, 2, 3, 4, 5 to B. That makes my B prime go here. Here's my D prime, and here's my C prime. And that is flipped across the y-axis. So right here would be my y-axis. That would be my line of symmetry or line of reflection. Line of reflection is what I meant to say. We can also flip it across the line y equals -x. The equation of this diagonal is y equals -x. And by the way, this is the x-axis. And if you have a diagonal going bottom left or top right, that's y equals x. Those are the 4 lines of reflection that we'll talk about. Okay, so this one's a bit harder. So I am going back to my patty paper. And I am going to draw this line, y equals -x. I am going to outline my shape, and then I'm going to literally flip it across that line. When I flip it across the line, I'm going to trace it on the other side first. Okay, so let me go back and match it up again. So I am right here. I'm going to lift this, make sure that I put it in the right position. Yep. My A prime, B prime, D prime, C prime. So if I were to fold it on this line, it would map on top of itself. So we should notice some things. And that is when you do it across the X or Y axis, it's much easier to count, but it's not that easy when we go across a line of reflection. So if I were to connect A to A prime right here, and it's going to intersect your line of reflection exactly at a 90-degree angle. The other interesting part is that the distance from that intersection to A and A prime is the same, or the line of reflection cuts that distance exactly in half. So I could have measured from A to the line, and it looks like that's about 1.5 inches. And then I could have gone 1.5 inches to the other side and figured out where A prime was. And that works for all of them. Like I can connect C to C prime. That's going to be a 90-degree angle, and the two segments, whatever these are going to be the same. So that helps you graph. It also helps you find the line of reflection if you're given the pre-image and the image. So what you start with is called the pre-image. What you end up with is called the image. My A was at 3,4. If I flipped it across the y-axis, my A is now at negative 3,4. It's right up here. My A was at 3,4. If I flip it across the line of reflection y equals negative x, I am at negative 4 and negative 3. So those are lines of reflection. Oh, let's talk about what we need. Need a line of reflection. So that's what we need to do a flip. Okay, next is a rotation, and those are turns. And what we need here is, right above, is where we will need a center and angle of rotation. A says we're going to rotate the square 180 degrees. Positive rotations are counterclockwise, and negative rotations are going to be clockwise around the center of the origin. So this point 0, 0 is the center, and then we will trace it. So here are the steps. I am going to connect my center, 0, 0, and I will pick A. Now, the tool needed to measure angles is called a protractor. Looks like this. So I am going to line up. There's usually either an open circle, or mine has these two black lines that meet. And 180 is actually off my page. What I do know, though, is that 180 degrees is a straight line. So I measured 180 degrees, and I made a little mark down here, and then I connected it, but I knew it'd be a straight line. To figure out where A prime goes is you actually measure the distance. So from A to that center, that's about 3, and about 3, be about right there. So this would be my A prime. The next one I will do is B. So I'm going to connect it to B. I would use my protractor to figure out where 180 is. Just write down below. And again, I know that that is going to make a straight line. We're going to measure again. So 0, it's a little bit over 4 centimeters. A little bit over is about right there. It's close. Not exactly, but close. Okay, so now I have B prime. So if I'm picturing a square, it's too big, but I'm still going to picture it, right? So I'm going to hold it here and turn it. So the rest of it should come below. That helped me visualize it. This would be D prime and C prime. I could use patty paper again. Didn't quite put that in the same spot. And I don't know if I have any extra on my desk right now. No extra patty paper. Let me do something else. Another tool we have is our compass. Compass they draw circles, right? So if I zoom out a bit and I am going to put this compass point in the center, my opening is going to be at A. And I don't have to draw a full circle, but I can draw, it's like a path. This is where I would rotate A. So I'm going to do the same right here for C and see if my C actually ends up. And it does not. So see, I didn't put it in the right spot. So here we go. I made a mistake. It's always good to double check, right? Like I had a feeling maybe. So this is a no, a no, a no, because my C has to be here, my D has to be there. And I checked that by following the path because I only moved A and B and I was trying to figure out if my square was going to go above or below. And I figured out it goes below. And if I do it with D, I can see that that's going to end up in the right spot. D is going to be right there. So I feel good about that. So let me maybe shade in the one. See, even teachers make mistakes. But I'm putting a lot of thought into if my answer makes sense. When I was looking at the path, red flag went up. It's like, oh, maybe that's not right. Okay, I feel good about my answer now. It goes up here. Let's do the second one. We want to rotate the same square 90 degrees clockwise. So negative 90 degrees means I'm going to go clockwise. So D and B are on the same line. So what I'm going to do now is I'm going to use my protractor. I'm going to put it along the line B and D, and I'm going to measure my 90 degrees. So if I connect my center to this, it should be this right here is now my 90-degree angle. So before, this big angle right here was 180, but now I'm going 90. I'm going to use my compass because I've had good luck with that. And I'm going to do B. And I'm going to do D. Looks like it's a bit too big. Let's see. I think my D prime's here, my B prime's here. Okay, now I have to visualize it again. So if I do this, so my A prime's here, C prime's here. I think I'm good about that. So this is the image after a 90-degree clockwise rotation. Let's see. Okay, point A was at 1, 3. Where is it after the 180 at -1, -3? Right down here. If you do the 90 degrees, this A ends up at 3 and -1. So we needed a center and an angle of rotation and a bunch of tools. This is why GeoGebra is so nice, because we don't have to do it by hand, and it will do the shape for us. One more, and that's the scaling or dilation. So we also need a center and you need a scale factor. And we talked about scale factors when we talked about similar triangles. So 0, 0 right here is going to be our center. And you can measure any of the distances. And then the scale factor is going to be 3. Yep. So I'm going to make it 3 times as big. So I'm going to do this one first. So it's just one diagonal. I'm just going to count to 3 diagonals. That makes this d prime. If I go from 0, 0 to b prime, I can measure it again. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. My b prime would be here because I'm multiplying the distance by 3. And I am going to bet, since it has to be a square, that my c is going to end up right down here. Let's see if that's actually true. So if I measure the distance, it's 3 centimeters and 9 centimeters. And then a prime should be up here. So when I'm done, I will have a square that is similar, but 3 times as big. So if I look and I go, let's call the center O. If I go from O to C, and I multiply it by 3, that's going to give me O to C prime. So that distance times 3 times the scale factor gives you that total distance. This was 3 centimeters. This is 9 centimeters. This side is 2. 2 times 3 is 6. This side is 6. Point A was at 1, 3, and now it is at 3, 9. Again, just multiplication. Okay, this lesson is just to kind of show you how to do these by hand and maybe how much work it is to do them by hand. We will not do them by hand in the homework or on the test. This is just the demo for you. From here on out, we're going to use GeoGebra to do these.